buzzwords in the industry. Cloud Foundry is an open platform as a service, or PaaS, project initiated by VMware. My employer purchased Gemstone. It can support multiple frameworks, multiple cloud providers, multiple application services, all on a cloud scale platform. And we'll be looking at how Smalltalk fits into this technology. If we think about the typical IT delivery situations for your servers, the typical place things start, particularly in a larger enterprise scale environment, is self-hosting. This is something where your own IT department provides network, power, air conditioning. They have the hardware. You need more CPU, you put in a requisition to the IT department, they install it, you deal with RAM, disk. We're currently going through the discussion of how much disk do we need on this server and that server. Then you're also responsible, of course, for the entire software stack, the operating system, which version of Linux are you going to be running? Do you have all the patches on it? What web server are you going to use? Apache, or are you going to use something else? What databases, which version of MySQL, the runtimes, the frameworks, and so on. All your responsibility for your IT department. Then, of course, the application is the thing that you're writing. That's where we as programmers are wanting to spend our time and do our work. So with self-hosting, you don't get any help with any of this. If you go with a co-location or a data center, you generally will be hiring someone to provide a rack. And then you can haul in your own hardware. If you want a new Dell machine, you go out and buy a Dell machine and then drive into the data center, put it on the rack, plug it in. Again, someone else is going to be responsible for making sure there's power, UPS, dual network directions coming in from two different points so that if somebody cuts a cable. So you're getting some responsibility for some things. The next level is infrastructure as a service. And we're familiar with Amazon, EC2, things like this, where you can hire someone else who provides the hardware as well as the utility and structure. So there you get a kind of bare metal Intel machine, and you can install on it your Linux system of choice. You can install on it, and you're responsible for making sure the patches are up to date. The next level, where we're going to be spending our time here today, is on PaaS, or platform as a service, where in addition to the utilities, the hardware, someone else, an outside provider, is giving you an operating system, web server, databases, runtimes, frameworks. And your only responsibility is to provide the application. So this is where your concern is. Now, of course, there's the last level of software as a service, and this would be something like the Salesforce app, where you just pay someone, you get a login to an account, and you can keep your customer management database, or and then all the windows and everything, it's all there. So we're not as concerned about that level. We're the programmers. We want to be responsible for writing the application. We just don't want to have to deal with all the other parts of it. And so here's where Cloud Foundry comes in. The promise or tagline is deploy and scale applications in seconds without locking yourself into a single cloud or a single provider. Some of you may have heard of Heroku, other things, Google Apps. These are providers where you submit your application, but it needs to be the type of application that they support, and it needs to use the tools that they support. And once you get started using their tools and environment, you're essentially locked into that. With an open architecture, you can use what you want, you can move when you want to. So the general approach that we're going to take is VMC target, and then you pick a cloud provider. So this is the command line tools. You target a cloud, you push your application to the cloud. If you want to, you can bind some services, such as database, to it. And then you can say how many instances you want. So the scaling, you could, if you had the right cloud provider and wanted to budget for it, you could go and just add 100 instances of your application if you need to scale. So the idea is that this is simple. We're going to let the developers focus on their code and not wiring up the middleware. Open. Avoid lock-in to a specific cloud, framework, or service. Completely open source from day one. And then flexible, where you can adjust what you need when you need it as the developer or the entrepreneur responsible for the application. And there's future innovations. It's an open source project. You can add to it. And in fact, we're adding to it here today. For developers, you write code. You don't write tickets asking for resources. You just write your code, push it to the cloud, and it's up and running. But of course, we're not trying to make the IT people bad guys. They have a role in this too, and their job is more self-contained when what they're doing is providing infrastructure and not having to deal with those developers who are always changing their mind. They just provide a cloud, let you scale it, and deploy what you need. We have a kind of triangle of resources here. So the first thing is a choice of frameworks. And this is in the built-in cloud as it's delivered in the original base implementation. There are a variety of frameworks. In Java, Grails, Spring, Scala has Lyft, Ruby has Rails and Sinatra, Node.js is available. These things are built in already. And it's open source. You can add other things, contribute it back. It may get added in. So people have added in Erlang, Python. If you're running on a Microsoft operating system, then you can run .NET and PHP as well. So these are options that can be added. Cloud Foundry supports services, and there's a protocol for how you interact with services, and they can be used. So there's data services, messaging services, other things. And various things are built in. MySQL is part of it. Redis, other things. Okay, there's so vFabric, MySQL, Postgres, Rabbit, RabbitMQ, Redis, MongoDB, so on. And then other things could be added. Then there's the cloud provider. So we have the frameworks, services, and the providers. We can do this through private clouds. So you can run your own cloud and have this. Public clouds, there are commercial vendors out there who are offering Cloud Foundry services. And then there's something called a microcloud that we'll look at, where you can create a cloud on your laptop and do your own test deployment with it that way. So, cloud on a stick, cloudfoundry.com, other partners, and then private cloud. So, you can make use of both public, private, you can deploy in multiple places, you're not locked in, different locations, geography, peak load, and manage your change over time. different providers of private cloud, different providers of public cloud. AppFog is located in Portland, and they're doing some hosting of Cloud Foundry. And then different infrastructures. You can, if you want to, use Amazon Web Services. Get a Linux box, and then install Cloud Foundry onto it, and then point yourself to it, and now you're running using their infrastructure and Cloud Foundry. Other places offer different things, so this is available. One of the places, at least for kind of demo proof of how to do it, is Cloud Foundry itself, cloudfoundry.com. VMware is offering this in a beta phase. Not sure what the direction is for charging in the future, or if we're going to encourage people to go with partners on that, but it's currently available with a variety of frameworks and services running on a large server farm that is being managed by VMware. There's microcloud. You can download, install your own microcloud, and run, again, runtimes, frameworks, a variety of things on your laptop. I have one here on my MacBook. Open source. So a variety of things have been added to it through cloudfoundry.org. Cloudfoundry.org is the focal point for the open source aspect of this. And it's available on GitHub. You can clone it and just start to use it. Then you can download the code, set up your environment, run the chef scripts, deploy it, and you're off. The general logical view of how this is structured. This area is the server, the Cloud Foundry side of things. There's a VMC client, which is what runs on your machine, command line tools that allow you to push code to the server. There's also a plugin for Eclipse. Then, of course, there's the browser, the user side, the application, the web browser, where you're running, accessing your application. Inside Cloud Foundry, there's something called a router, or routers, that take the requests from the various places out on the web and decide whether to send it to an application, to the cloud controller, or somewhere else. So this is how we interact with it. For the developer, we're going to be using the VMC to interact with the cloud controller. If you're a user, you're going to be using a web browser to interact with the application. So this is how we interact with things. If you're in a web browser and you type in an application, the request goes, the response comes back. The request goes to a load balancer and routing. The router then picks an appropriate application, and the app instance receives the request. So here the request is going on port 80 because it's an HTTP request. The router, though, because there can be multiple applications on this one host, all running in their own environment, they each need to be listening on a separate port. So when your application starts, it is given a port number. It says, rather than listening and running your web app on port 80, you're going to listen on port 4, 5, 6, 7, 8. And so the communication here is on a unique ephemeral port that is changed each time the application is launched. The application can then has its own web interface or HTTP server, your own app then, and then you may have some services that you're interacting with. If we are scaling things, we can have multiple app instances. And so the load balancer, when it receives a request for your application, will send one request to this app, the next request, and cycle through, sending me requests to different instances of your app. And so if one of them gets busy, you see that you're getting lots of requests, your application is busy, you can just add instances, and they may be on the same host or different hosts, and things will get routed to them appropriately. If you have pushed your application and want to update it, want to make changes to your code, well, you start by just saying, here's the old version, you stop your instance, you update the code, and then there's a new version. And so people were interacting with the services here, and now they're interacting here. So there's just the command vmc update my app, and now it's doing something different. Your new code is now out there. So I sent out emails last night to everyone on the list that I was given. If you are interested in trying it out and have the email, then you can refer to that. If you don't have the email but want to try it out, I have the user ID and password. Monty also has it in back. He's waving there. And so you can get your user ID and password from him and try it out, follow along. I'll be around all day today. I'll be here all day tomorrow as well, and we'd be happy to work with people on this. The basic idea is that for the client, you need to have Ruby and Ruby gems installed. And so there's some instructions at cloudfoundry.com on how to install Ruby, Ruby gems, and get your environment ready to install it. The usual thing that the instructions say is install VMC. We actually have a special version for us that's VMC stick. And so we'll want to do a gem install VMC stick. And that will put onto your machine the client tools to interact with the cloud. And then log in. And you can change your password. So I'm going to bring in my environment. And so I am currently logged in. So I can say VMC info, and that's pretty small type. So I'm going to see if I can increase it for you. So VMC info. And that tells me I am currently connected to a cloud named api.smalltalkcon, that's smalltalkconference.org. So api.smalltalkcon.org, and the client version of VMC. My user is Jay Foster at VMware, and I have one service running and one app running. And so that's kind of my information. I can say VMC apps, and it will tell me which apps are currently running, what services they're using, and so on. So I have an application called James Topaz, 2 of them. I'm going to change to a Ruby directory. And I have one file in it called ruby.env. I'm sorry, env.ruby, RRB. And this file is something that just says require Ruby gems, require Sinatra, disable protection because there's some firewall issues that the way the routers are doing it thinks that there's IP spoofing. On a get of / we want to put out hello from the cloud with a host and port. A get of environment, we want to do something else. So I can say VMC push, and it says, do you want to deploy from the current directory? Default is yes. James Ruby. It's going to deploy it for a URL of james-ruby smalltalkcon.org. I'll take that. It says it looks like a Sinatra app. Yep, that's right. We'll use 128 meg. I'm going to give it 2 instances, and I don't need any services. And I'm not going to save it, so it uploads it. It packages it, uploads it, stages it, and starts it. And so I can then go to cloud, or to a web browser and say James-Ruby Smalltalk on, and it says hello. And so we are now running here. Notice it's listing on this IP address is the server that's behind the firewall. This is where the host thinks it's running. It's on a port 34987. If I refresh this a few times, we might get a different port number. So now it's on port 58704. So the router chose to send this request to a different instance. So that's some of the things that we can do here. Is install it, target, log in, change your password, create an application. You can try out the application locally to do some testing development, push it to the cloud, view the application, run multiple instances of it, change the number of instances up and down, and then when we're done, we can just say VMC delete James-Ruby. And it just says, okay, we deleted it. And so now it's no longer running. So again, the push process is create the application in the local environment, package it, upload it to the server, and stage it and start it. So we're interacting between the laptop and the server. Now, the server architecture that we have, that I have set up, that we've been given, we're doing our VMC client in a web browser. We are talking to a router, firewall, proxy server that's on the internet at 64.20.104.5. So this is something that VMware owns and takes requests and routes them. So we're pointing smalltalkcon.org as that, and then we've configured that router to say anything in this domain send to me. Okay? So then this router gets the request. It looks at the HTTP header and says it's a request for James-Ruby, James's Ruby app. And so the James's Ruby app is going to be on port 389, something. And so it takes the router and sends it there. When I'm dealing with the client, VMC client, then I end up going to the same thing, but the router, I'm using an API that is talking to the cloud controller. So we have a cloud controller, the application that we're actually running, something called a droplet execution agent, or DEA. This is responsible for starting, stopping, watching this, reporting the state to the health manager. And all this is running on something that internally we identify as Gemstone Smalltalk Cloud Foundry 1 in the Wenatchee data center. Now, we've said that there's built-in frameworks, but wouldn't it be nice if Smalltalk were part of that? And we've said that there are built-in services, and wouldn't it be nice if Gemstone were a part of that? So, it's, we like working in Smalltalk. The rest of the world isn't as familiar with the way we do things. The traditional programming model for Ruby is there's an interpreter that works with text files. The application code includes external libraries. The framework can be preloaded on the server. With Java, Scala, Ruby, we have a runtime VM, but there's jar files. So again, there's something small and self-contained that you just push to the server. And the application code can include something that's already there. So we can preload the cloud with the things that you're likely to want. And so all the frameworks, Spring, Lyft, Rails, Sinatra are already there. You just say included. But Smalltalk, you may, shouldn't be a surprise in this crowd to hear that Smalltalk is a bit different. We do have our monolithic image with the full application framework, and everything else is already in this one monster. And even if you're dealing with something comparatively small like Pharaoh, we've got 25 or 30 meg image and 25 or 30 meg changes file and another 10 or 15 meg of sources file. So, we've got 75 meg of stuff. And every time you modify your application, pushing 75 meg to the server is not a very easy way to do this. This does not fit in with the Cloud Foundry model. Yes?
Is the bigger problem not pushing to the server because you can always file that? Is it the fact that you have to persistently run something?
Do we have to persistently run something? It turns out that's not the problem because we have to do that anyway. Because the way Smalltalk execution works, you have to have an image, you have to have a VM. So we are going to do those things on the server. It's more just a matter of do we want to have to push it. So we could actually do it, with just here's the 75 meg and use it. That would be the simplistic way of doing it. If network traffic weren't an issue, you were internal or microcloud, yeah, that would be doable. But for purposes of trying to see how this all works, the exercise that I've gone through is, well, we can make Smalltalk behave like some of the other things. And so let's take a look. You actually, as a good engineering practice, you actually should load your code into a fresh image. Okay? We've heard horror stories, and some of us have worked on projects where you hand around an image that's been handed around for years, and no one knows how to build a new image, and it's just impossible, and so everybody just copies this one. Well, that's not a good engineering practice. It's a good engineering practice to be able to load your code into a clean image. So we say do that. You have a package or a file name. So if you start with a file name or a package, then we're actually just shipping our code. And if the server has an empty or blank or virgin image, then we can install code into it. So the staging process is launch Smalltalk, load the code in, save a new copy of the image, and then put that copy of the saved image into a directory, and then each time you start up a new instance, copy out that saved image into a new directory, into the droplet environment, launch the saved image. At launch time, we have to have code that determines what port to listen on, start an HTTP server. And so I've done this with Pharaoh and Ada, just as an example, pick something to work on. I think it should work equally well. I know that some of the people at Potsdam University have done it with Squeak, and conceptually, I would love to see it done with Syncom Smalltalk, VA Smalltalk, other things. Yes?
This is very close to what I do for blog server.
Yes, okay, your blog server, you've got an image out there, you have a package, you push it up there, you make changes locally, test it, and then you just have a push command that just takes it. But you've built,
This is way more important.
you've built an infrastructure to go with it, and you're managing the infrastructure to go with it. And it'd be nice if you could outsource that. But yes, conceptually, yeah, this is all familiar territory if you kind of squint and look at it sideways. It's kind of, oh yeah, we've been doing it. James has been doing that for a decade with his blog server. So the environment we set up is have an app directory that has a Smalltalk image or a Smalltalk source code in it. And then outside that directory, we have the image, changes, debug, sources. And then the start command says, you know, start up a cog VM on this image with this start script, pass in this port number. And then our start file is change the default directory from the parent down to the child so that we're in our app directory. And then load, you know, open with a file stream, read ada.st, and get the contents, and then evaluate this content. So this is just loaded in and executed. This is just our startup process. Then, you know, the Ada application itself, pick up a port number, get a default, stop the server, change the port, start the server back up. And then add whatever other code you want. So, and again, this could be arbitrarily complex, loading MCZ files and that sort of thing. So what do we have to change to make this work on Ada? Well, on the client, we have to change VMC, the client, so that instead of recognizing a Ruby app, it recognizes an Ada app. So there's a few lines of code we make changes there to say recognize and support Ruby, push it to the server. On the server, we have to make a number of changes so that as part of deploying the Cloud Foundry, it downloads COG, it downloads an Ada one-click image, it puts them all in the right place, it sets up some scripts that can stage things and deploy it. You know, fair amount of work, but it's all there and it's done. And I've demoed this, and I have some screencasts and blog posts that show a screencast of pushing the Ada application to the web. Gemstone. You know, of course, again, this is public source. You know, we can try it in a variety of areas, but my passion will be for can we get Gemstone to run in the cloud? So there's MySQL, MongoDB, Redis, and so on. Gemstone is, it's an object database instead of a relational database, but it should bear some relationship there. We do have a runtime, command line called Topaz, so you can type commands in. We have support for filing scripts. In a Topaz, you can say file in some source code. So what changes? Well, we need to recognize Topaz as an application. We need to be able to look for it and send things to the server. So VMC is modified there, and I got some help from Johnny T here for building our custom stick client tools. So rather than having to tell you to edit VMC, we just have one that's pre-built for you. So our server architecture is now a little bit more complicated. Previously, we had our VMC client and web browser, the VMware firewall that takes Smalltalk conference or routes it to our own cloud controller on CF1, and the router, the cloud controller. On this machine, I have the router, the cloud controller, the health manager, and the Ruby execution environment. But we've got 3 other machines that we've got in the data center as part of this. And so Gemstone, Smalltalk, Cloud Foundry 2, Cloud Foundry 3, and 4. Number 4 has the big disk, and it is running Gemstone database server. Cloud Foundry nodes 2 and 3 are dedicated to being Topaz execution environments. And so we have our Topaz application instances can be deployed to these machines. So we've got all the requests come to the router. The router says, if it's for a Ruby app, send it to the appropriate Ruby app. If it's for a Topaz app, then figure out where the Topaz app is and send the request there. And the Topaz app will run and send the response back through the router, through this router, through that router, down to the web browser. So, if you'd like to try that out, we have on my blog here, Programming Gems on WordPress.com, I have a Ruby script, a Topaz script, and we can copy that out and put it into a Topaz file. It's kind of small here. You can look at it on your screen, or you can come back and discuss it as we have time. But what I'm going to do, is go back to here. I have things running at the moment. I'm going to delete that. And I'm going to delete the services that went with it. So imagine that there's nothing there. So cd Topaz, and in this directory I have a file main.tpz. Okay, my main.tpz does various things. It obtains a lock, it installs some software, and then it removes the lock, and then it picks up the port number that it's supposed to run on, and it starts a foreground server on this port, and that runs indefinitely. Okay? And so you can take this code, put it into a local directory, and then say vmc push. Do you want to deploy from this directory? Yep. What's the application name? James Topaz. So we'll put it at this URL. Yes, that's good. Okay. This looks like a Topaz application because it has a file named main.tpz, and that's our hint. Is this correct? Yes. Memory, take the default. How many instances? I'm going to say deploy 2 instances for me. And do we want any services? Critical here, Topaz applications, we need to always say yes, because Topaz isn't much use without Gemstone. So it's going to be a Gemstone service. And here's a list of the services that I've provided on this private, public, quasi-cloud. So we have only Gemstone available. I'm not offering you MySQL or Redis or MongoDB. And you can give it a name or just take the default. And do we want another service? No, this will be fine. Do we want to save it? No. We're going to create the application, create the service, bind the application to the service, upload things, stage the application, and then start 2 instances of it. Okay? So we can then go to to web browser, and this time we'll say James Topaz. And it comes up. Now actually, if this were the first time I were doing this, it would ask for a password. You may have seen in the code, I put a password in because this is kind of in the public, and it's not just running an application. The application that I'm running here is something called Web Tools. And this Web Tools is a web interaction with Gemstone, where we can go and see things like, what node is the stone running on? It's running on CF4. What node is the Topaz running on? Well, it's running on CF2. And what's the operating system, what process, what build, what OS, and that sort of thing. So those are things that we can see about the version, so version information. I can also go to a code browser. And so when I open up a code browser on Gemstone, in Web Tools, I see a list of my dictionaries. And so those of you who are familiar with Gemstone will recognize the dictionary list. Web Tools is one of the ones that's installed, because this is what I'm actually running, is the Web Tools. And so, for example, here's the code that is running Web Tools. I am running a foreground server on a particular port. So I start a port, GS file, standard out, self-server URL. Notice the underlines in green is the message sends, and actually these are step points in the method. And so if I click in one of these areas and then right-click, I can see this is step point 4. And so who are the implementers of server URL? And so, well, server URL is implemented in this class, the category, and method, and so on. So I can go look at those things. So I can also, browse around, look at other code. So here's array, here's array app. You can see the hierarchy chain. So these are the superclasses for array. And then we can also see the implementation. So app is implemented in array and in object is the two places that that's implemented. And isolated from everyone else. So here you have your own user in Gemstone. But we're also running on a Linux system, operating system. System perform on server. Who am I? What host am I on? And where am I running? So let's take a look at that. Well, the Unix user ID is vcap user1. The machine that we're running on is CF3, and the directory in which we're running is var vcap local DEA apps James Topaz instance 1 blah 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 app. Okay, and we can do things like system perform on server. LS, say LF. Okay, and so this is saying, well, the files that exist in the home directory for my application are this. And, we want to have some security. System perform on server. We don't want you accessing the root directory. So touch/foo. And so, no, permission denied. You're not allowed to do that, okay? But one thing interesting here, we said, actually that's user ID. Notice that when we do this perform on server and look at the who am I, host name, and password, this time it's CF3 user1 in this directory on this node. If we repeat that a few times, we might get something else, okay? So here, I repeated it, and this time I have vcap user 1 on Cloud Foundry node 2, as opposed to node 3. And here it's in a directory called Topaz 0 instead of Topaz 1. So I am running on, I'm making AJAX calls to the server through the router and getting to the server, and the router is picking a different instance of Topaz to respond to each request. So sometimes it's the machine host on CF2, sometimes it's CF3. So I have two instances running here. Hard to compete with that, isn't it? So we can, there's some issues about deploying the application, only loading the code once, so making sure the first time we load it, but not the second time. And we can push it and take a look at various interesting things. Limits, this is a proof of concept. Just, can we put Smalltalk in the cloud? Yes, we can, okay? Which, isn't a big surprise, but it's still been a non-trivial amount of work to do it. I've given you user ID and password to the site. Please understand this is, proof of concept, testing, just sort of a light playground, no endless loops, no creating billions of objects, and do not deploy your mission-critical customer-facing applications there, because I intend to just randomly go out and kill processes and shut the site down and start it up again. It's here for us to play with for a couple days, if we're careful. However, the people at the VMware data center are nervous about us doing this, so be careful. There's a microcloud. You can download, run a microcloud. That way, you develop locally, test pushing it to the server. Once you've got everything running, you know that you're pushing it to the server and it works, then you can deal with it. So, platform as a service, it's the future. It's where things are going, or at least that's the current marketing type. Cloud Foundry is open source. This is not a VMware plug for a commercial product. This is download it, use it, extend it. You can go to cloudfoundry.com, cloudfoundry.org. You can download your own, the blog. I'd like to thank Dale, Peter, Monty, who did a lot of the work on this early on, and then Johnny for helping yesterday, and Norm, VMware for the opportunity to do this. And we'll take a few questions if you have some. Or we can just go directly to the break. Yes, microphone is coming.
I'm just curious, the protocols that need to hit the outside routers, that is just HTTP, or could it be also other protocols?
It's just HTTP. So actually, if you go to something like this and say HTTP API Smalltalk, you're actually communicating there. If you say something like /info, it will give you back a JSON document that describes something. So all of the interaction is a RESTful API to Ruby Sinatra app that does stuff. Yes, the mic's coming. Mic is coming.
I mean, I'm just wondering, like, how much a user would be charged for this? I mean, I have a number of peer applications, and that could be like a perfect cost. But then, how much would it cost? Do you have an idea?
Well, I tell you this: if I could get 1,000 people to pay me $20 a month, I'd quit my job and do that. But I don't think that there's going to be 1,000 people that want a Smalltalk app. I don't think that, for VMware, it's a matter of, is there a business proposition here? And I have no idea. You could go to Heroku and say, how much does Heroku charge for a Ruby app? I don't know. You could start a business. All you need is an Amazon server and download this, create it, and start charging for it. How much would an Amazon server cost that would run it? I don't know. Again, this is proof of concept. Can we get Smalltalk in the cloud? And we can. Whether there's a business model here, I have no idea. That's why I'm glad I have a day job that pays a salary. Because I don't seem to have the business But the ideas don't seem to have borne that fruit.
Your load balancing model does not allow sticky session.
My understanding is that Cloud Foundry does have the option of supporting sticky sessions. I haven't looked into that. For Topaz and Gemstone, I don't need that. For Ada, you would need it. So, yeah, don't know. But yeah, the documentation says that it is an option. Okay, well, I'm going to be around, and I'd love to help. Johnny, I think, will be the one to ask if you need help getting the VMC